Hello students, in this part of video we are going to talk about the mechanics. Later we will understand what is the kinematics and as well as the dynamics by understanding the term of mechanics. What is the mechanics? It's a branch which explains about the state of rest or motion of the bodies. State of rest and motion of the body. Okay. Here mechanics is further divided into two parts. One is statics and second is dynamics. Okay. One is statics and second is dynamics. This dynamics is further explains about the motion of the body with the kinematics. Here we have to understand what is the kinematics is. Okay. What is kinematics is? What is kinematics here? Kinematics is the branch of physics which deals with the motion of the bodies without the reference of cause of motion. It explains us about the motion of the bodies without the reference of cause of motion. I mean, it didn't explain us why the body is moving, who is making the body to move, from where it is started, okay, how it is started. Here it didn't give any kind of reference of cause of motion. But dynamics explains us about the cause of motion of the bodies. I think you are understanding. I can write here. What is this? Without the reference of cause of motion. Okay. Without the reference of cause of motion. It's the kinematics. The kinematics explains us about the motion of the bodies without the reference of cause of motion. And what is statics? It explains about the state of rest of the bodies. State of rest of the bodies. Okay, maybe the body is in rest under the effect of the forces. Okay, when equilibrium forces are acting on, the body is kept in equilibrium. If the forces are acting on a body, the body may be kept in equilibrium. It is. To understand the kinematics well, here we are going to learn about the kinematics only. Here you have to come across with so many terms which are related to the kinematics. Okay. Kinematics, I told you, it's a branch which deals with the motion of the bodies without the reference of cause of motion. To understand kinematics well, first of all you have to understand what is the frame of reference. What is the frame of reference? First try to understand this. Frame of reference. Okay. Here with the example I will explain. Listen my words carefully. For example, you are standing here. It is you or me standing here. Okay. And say it is a bus or a car which is on the road. Okay. I am observing the car. I am observing the car. Getting me? Okay. And imagine that in the bus or the car, two fellows are sitting. He is the one and he is the one who is sitting in the car. Okay. Here I am observing the motion of this car. It started, it is moving. It is started and it is, the car started and is moving in that direction. Here I am observing the bus. Okay, I am taking a coordinate axis system here. It is with reference of me. Okay, say I am standing at the origin. Here, it is a two-dimensional plane I am taking. Say it is X, it is Y, and it is Z. This is the frame of reference. What is the frame of reference? It is the imaginary coordinate axis system in which the motion of the body can be observed. Okay, it is the imaginary coordinate axis system in which the motion of the body can be observed. Now watch. Here I am observing the motion of the body. Okay, see, the body appears to be this one. The car appears to be moving. Understand? But think about the person who is sitting in the car behind the driver. He felt that he is in rest with respect to the driver. Here I am drawing one more reference coordinate axis system. This is the X dash I am saying, and it is Y dash, and it is automatically Z dash. Okay, now think here in this frame of reference. Okay, X dash, Y dash and Z dash. Okay, the people who are sitting in the bus felt that they are in rest, but in this case they felt that this person felt only these people are in motion. He felt that the two persons who are sitting in the bus are moving. It is the frame of reference. Frame of reference is the imaginary coordinate axis system in which the motion of the body can be observed. I hope understood. Here we have so many frame of reference there. One such frame of reference is Cartesian coordinate axis system. Okay, here in this one, you know that this is Cartesian origin. We are taking X and it is Y, Y dash and X dash. This part we are taking it as a positive and this one is negative. The same thing goes on. It's a Cartesian coordinate axis system, and this one coordinate axis system, right hand coordinate axis system. And we have one more. What's that? Ground coordinate system. What's that? Ground reference frame. Here I am standing and observing. And one more, geographical coordinate axis system. What is that? Geographical. Okay, here you are aware of that. We consider it is the North Pole and it is the East. Okay, in which we observe the motion of the body. Understanding me? Okay, it is about the coordinate axis system. Here, depending upon the coordinate axis system, kinematics is classified. I think you understood. A frame of reference is the imaginary coordinate axis system in which the motion of the body can be observed. Okay, we have different coordinate axis system. Generally, we take the right hand coordinate axis system. Depending upon the frame of reference, the motion of the body can be classified. Okay, in three methods. One is one-dimensional motion, second is two-dimensional, and third, obviously, the three-dimensional. First one, kinematics, can be classified the motion of the body. One is one-dimensional. Okay, the second one, two-dimensional. And third is the three-dimensional. First of all, we have to understand it is 1D, it is 2D, and it is 3D. Before understanding these types of motion, one-dimensional, two-dimensional, and three-dimensional, we have to understand two terms which are very important in kinematics. The first set of terms, I'm calling it as A. It is rest, and the second set is motion. These two things are very important. First of all, you have to understand what is the rest is. What is rest? If the position of the body is not changing with the surroundings with respect of time, if the position of the body is not changing with the surroundings with respect of time, we call the body is in rest. Here I am writing what is meant by rest is. Okay, if the position of the body is not changing with surroundings with respect of time, the body is said to be at rest. Okay, students, if the position of the body is not changing with the surroundings with respect of time, then we can say the body is in rest. Okay, let's see. The second one is motion. How can we define the motion? It is very simple. The same as above. If the position of the body is changing with surroundings with respect of time, then the body is said to be in motion. If you watch it carefully, you will understand one thing. the position of the body is not changing. Here the position of the body is changing. Actually, you can't say any body is in rest or in motion. Okay, here what I have to say, rest and motion are not absolute. They are not absolute, but they are relative. Okay, they are not absolute, but they are relative. Understanding me? Rest and motion are not absolute, but they are relative. How can we say? The same example what I took before. Imagine that you along with your friend are sitting in a car and you are traveling. Okay? Okay, and for you this person appears to be in rest, even though the car is moving. This person appears to be at rest. Understanding me? But see, here it is the one frame of reference, and I am taking one more here. The person is standing here and he is observing. He feels that this car is moving. Even though he felt that he is in rest, but he feels he is in motion. That's why we can't say anything is at absolute rest or in motion. Understanding me? Here, what is the rest? If the position of the body or the object is not changing with the surroundings with respect of time, we can say the body is at rest. If the position of the body is changing with the surroundings with respect of time, we can say the body is in motion. This means what? I would be here only for coming days. Yes, only I am standing. We can call it as a rest. Okay, now I am changing my position. The surroundings with respect of time, my position is changing. Then I can say I am in motion. But I told you, rest and motion are relative. They are not absolute. Okay, one appears to be in motion or in rest if you have the same body in different frames of references. That is a very useful thing. Frame of references, very useful thing to understand the motion of the bodies. Okay, here we learnt about a set of words here. What is the rest and motion? And in next part we have to know about two more terms which are very important in kinematics. Okay, that is, the next set is what? Distance and displacement. Distance and displacement. Okay, these two things are very important. If you master the art of finding the difference between the distance and displacement, most of the problems which are asked in competitive examinations can be solved easily. Okay students, here we are learning about the terms which are related to kinematics. What I said, the first of the words are the terms which are very important in kinematics are the rest and motion. The second one is the distance and displacement. In 9th class maybe you learnt what is the distance and displacement is. Distance, it is the measured length between the two positions. It is the measured length between two positions is the distance. And what is the displacement? It is the shortest measured length between the 2 points. You can understand this thing very well. Here first we are learning about the distance. What I said is the measured length between the 2 points. Let's say a body started from A and reached the B. Okay, it traveled 2 kilometers. It traveled 2 kilometers. Here I am taking geographical coordinate axis system. It is east and it is the north. Okay, here with the reference frame we are observing the motion of the body. It moved along the east, okay, for 2 kilometers. Then after it took a turn and it traveled some 8 kilometers, okay, towards north, and it's the A, B and C. First of all we have to find the distance. Here distance is nothing but the path the body is traveled. Here it is, okay, the person is moving, got me? He traveled in this way and he traveled and he came to this point. Then what did happen to him? Here, then after he reached this position, okay, the person reaches that position. If you measure the length of this path, it is the distance. Obviously we can say distance traveled by the body is equal to 2 kilometers plus 8 kilometers. It is 10 kilometers. Okay, what does it mean? The total path of the body, the total path covered by the body is known as the distance. Distance is a physical quantity. It must have its units, isn't it? It must have its units. What are the units of distance? Distance is measured in kilometer. Okay, it is the practical unit. It is the practical. Okay, meter in MKs or SI and centimeter in CGS. Centimeter in CGS. These are the units. I hope you understood. What is the distances? Distance is the measured length between the 2 points or the path observed by a person. He started from here and he reached B, then after he traveled along this way and finally he reached the C. It is the path traced irrespective of direction. See, actually in this direction he has to travel like this, but he took a turn and he traveled in this way. That means every time its direction is changing. Do remember, while we are measuring the distances, we should not consider the direction of the body. That's why we call distance is a scalar quantity. It is a scalar quantity, and you know that what is a scalar is? What is a scalar? The physical quantity which has only magnitude without direction. This is scalar. Okay, to understand this concept well, watch my previous videos on vectors. You'll understand the concept of vector and as well as the scalar very well. Understand? What's the distance? It is the path observed by a body. Okay? Is the path traced by a body, irrespective of direction. And you have to remember, the distance, this quantity, distance, is always positive. Okay? This physical quantity, distance is always positive. Understanding me? Then after, we will talk about the displacement. I hope we understood what is the distances. Okay, now see, a body started from a particular point, from a same coordinate axis system we are taking. It started from A and reached the B. Meanwhile, it covered a total path of 3 kilometers in a particular direction, that is in east. Then after it took a turn and it traveled 4 kilometers along northwards. It is 4 kilometers and reached the sea. It is looking like the same thing what you have learnt here, distance, but here displacement and distance are two different positions, two different physical quantities. Now say the total distance covered by the body, obviously we tell it is equal to 3 plus 4, 7 kilometers, isn't it? But what is the distance? Displacement. Displacement is the shortest measured length between the two positions. It is the displacement. Okay? AB plus AC is equal to 3 plus 4, 7 kilometers. What is this distance? Okay, distance is 7 kilometers. And we have to find out the displacement. Shortest measured length between the 2 points is the shortest measured length. AC, we need to find. AC is equal to under root of AB square plus BC square. Getting me? And what I get? It is 3 square plus 4 square under root of 25, and it is equal to 5 kilometers. See this? I am putting a bar here. Here the distance generally shown with the letter S, and displacement, I put a bar here. It is the displacement. Okay? It is equal to 5 kilometers. I think you are understanding what is the difference between the two. The shortest measured length is the displacement, where the distance between, the measured length between the 2 points is the distance covered. Here, if it is written in this way, the distance is a scalar, I told you, but displacement is a vector. Displacement is a vector quantity. Okay? And you know that what is the vector is? It's a physical quantity which has both magnitude and direction, obeys the triangular law. Vector addition. Okay, it's a vector. Vector is a physical quantity which has both magnitude and direction, has to obey the triangular law of vector addition. Okay, then we are relating the distance and displacement. As you see, know that S is equal to 7 kilometer and S bar is equal to 5 kilometer, isn't it? Here simply we can write distance is greater than displacement. In this case, distance is greater than, maybe they reach the same position, A to C. One person started from here and he reached this position along this way. Okay, students, and this fellow, he started from here and he managed to reach the same position. Here it is shortest basal length. Maybe the destination is same, the paths are different. That's why I said distance is greater than displacement. It is a relation. Or simply we can write distance is greater than or equal to displacement. When it will happen? When distance covered is equal to displacement. A simple thing. If a body is moving or two bodies are moving along a straight line, if bodies are moving along a straight line, the distance covered is equal to displacement. And you have to remember one thing here. Displacement is either positive or negative or zero. But distance, it is always positive. I told, distance always positive. I hope you understood the introduction of the kinematics and also what is the difference between the distance and displacement. In coming class, we are going to learn about the same topic with few examples and also by the help of position vector. By the help of the position vector. Thank you for watching my video. Subscribe my channel to get the latest videos on Inter First Year Physics.